This
Afternoon, ma'am.
conference will now be recorded.
Good afternoon to all. It's my pleasure to welcome you all for the second day training on design on electronic circuits for electrical engineers. On behalf of management, principal sir and HOD ma'am, I would like to extend a special welcome to our today's speaker, Mr. Ganesh Skandha. He has been working with microchip technology and has 10 years of experience in the field of electronics and communication. His primary work revolves around the designing hardware for RF like BLE, Zigbee, Wi-Fi, and simulation for RF and signals using ANSYS, MATLAB, etc. He also works with microcontroller and high-speed mobile processor. So we are happy to have such an eminent person here, sir. Once again, I welcome you. Now I'm handing over the session to Mr. Ganesh Skandha. Thank you, sir.
Thank you, ma'am. Hi, எல்லாருக்கும் வணக்கம். மேம் இன்ட்ரடியூஸ் பண்ணாங்க. ஸோ ஐம் கணேஷ். I have probably 3 hours of time with you, spread around this week, on Tuesday, probably Thursday or Friday, and then Saturday. I think it's Friday. So on this time, I think I will spend some quality time discussing a processor and controller specific. I'm sure that since you guys are in second year, probably you might not have worked with a processor like 8051 or an 8085 or anything for that matter. But I hope you would have done some amount of programming with an Arduino or in general in C and things like that. So I will try to make this session very simple, and since this is the first class, I thought I'll start with an 8051. I'm open for comments if you think this is a bit high level, and if you want to discuss basic electronic stuffs like transistors and do some simulation with transistors, diodes, and things like that, I'm still fine with that. This is more of an programming logic gate kind of an approach. So this is I thought this is more relevant going ahead for you guys than a more analog centric thing, which is very less in number. But I'm free. I'm open to discussion. So I'll keep monitoring two things which is an prerequisite is that I'll keep monitoring the chat window. If you have any comments, you can feel free to type. um, I've been doing a lot of sessions here, and I believe that an interactive session is very important for things to progress well. uh, to ensure interaction, I have a couple of quizzes in between with the processor and things like that. But if you have anything which is tangential to what I have, then you can feel free to type it on the chat window. I have most of the slides prepared, but sometimes I may just go to Google and show you something. So, and that's how I'm going to start the day. I'll start with an 8051 microcontrollers architecture diagram. Okay, so this I'll just use this picture for the discussion, and see if I can pop it out and just show that. Okay. And what we are going to speak about is called as a microcontroller. That has a CPU, pretty much like what is there in a mobile phone. So what we are going to do now is not very different from what is there in a mobile phone or what is there in your computers, laptops, inside your AC, washing machine, whatever you name it. And this has a variant of this, some variant of this. So if I take all the features of what everything does and then try to draw a generalized block diagram, this is how it will look like. So that is the CPU, which is the central processing unit. I think you will be learning it from class 6 or so. This is the core of processing. This does all the mathematical and logical processing of the instructions. So what it should do is stored on this program memory. Like if you want an AC, if you are designing an AC, you want the AC to be controlled by a press on the button. You want the AC to control the temperature, read the temperature, and what it should do is placed on this program memory. So that's the attribute of it. So this is like training a person to make a cake, or training a person to uh, make an clean an utensil or something like that. So when we do the training, what we do as training is very similar to what we do as programming. So that data is stored in the program. So let's say if you are trained to do an um, utensil cleaning, for that matter, you know what to do. You know, you take the utensil, you apply the wash into it, you wash it and you dry it and things like that. So that is a generic protocol. So that is stored on the program memory, and what it has to do is stored in the data memory. So for instance, the idea of washing an utensil is very common. For utensil na பாத்திரம், ஸோ நான் பாத்திரம் கழுவுறதுக்கு ஒரு எக்ஸாம்பிளா சொல்றேன். ஸோ பட் அது which utensil is it may vary. So for one day you might wash a plate, the next day it might be in cup. So the whatever is being processed might change. So that is what will be stored in the data memory. That's a RAM, which means it can keep changing. If I want to give a more appropriate example in case of an AC, if the program memory will be like, if the temperature is greater than 20, switch on the compressor. If the temperature is greater than less than 20, switch off the compressor. So something like that will be in the program memory. And the temperature as such is a data, and that will be on this data memory. So let's say someone has to ensure that the temperature is placed on this memory. So someone will write the temperature on a paper and keep it on a place, and if you are the AC's controller, you will read what is written on the paper. If the number is less than 20, you will switch off the compressor. If it is greater than 20, you will switch on the compressor. So someone's responsibility is to ensure that the data is ready and available to you. So that part can also be done by the CPU. For instance, if the data is available on a temperature sensor, the program memory can have an logic to go and read the temperature sensor and keep it on a data memory. So that is what is program memory and the data memory. Clock is the one which is trying to generate the pulse. It's like the heartbeat of your CPU. So only on every clock instance the CPU process. So it's as good as the heart for a CPU. And there are something called as input ports and output ports. If you want to, let's say you want to switch on the compressor, then you might have to turn on a relay. Probably relay is something which you might be aware of. Or if it is an LED, you might want to turn on the LED. So for that, you need to control an output pin. You have to make the pin either high or low. So that part is done by the output port. Input ports, let's say if you want to read whether a door is open or closed, we can put a sensor on the door, and if the sensor will give 1 if the door is open and 0 if the door is closed. So we can read back the sensor's value through this input port. So the entire logic revolves around the system. I can we started with washing an utensil on this slide, and we try to map it to an AC. We can still go ahead and map it to a cell phone. We can go ahead and map it to what is running, what is being sent to Mars by NASA, and everything works on the same principle. So that's a very generic architecture of how an CPU is going to look like. I can recap again. Program memory stores the set of instructions which has to be done. Set of step 1, step 2, step 3 is written on the program memory. Step 1, go and do something. So what thing this instruction has to be executed is stored on the data memory. The clock is like a heartbeat. Input ports gets an input from external world, and output port generates an output to the external world. With that logic in mind, I will go to an I'll go to an basic processor, which is an 8051. I know that's if you haven't looked at a processor like this can be a bit overwhelming, but we will try to take it step by step and see if we can understand what this guy does is. We looked at the block diagram. We saw something called a system clock. Uh, we discussed that that's going to be the heartbeat. So we have set the clock to be 12 megahertz. What I have is a simulator for 8051. It might be actually on a chip. You might have seen a chip. I can chip. You might have seen this chip. I don't have to show this, but just for the sake of it, I'm showing this. So what is here is the chip. So that's a chip, and this is whatever this chip does, we try to model it here, and this is a simulator for that. We call that as a simulator. Like we cannot let people fly. If we want someone to be trained on on driving an airplane, we cannot let him first ride an airplane itself because it's very costly. So we put him on a simulator, teach him how to drive it, and then only when he is good enough, we take him back to the aeroplane. So similarly, here we try to learn our logics with this 8051, and then you based on that go and implement it on a practical circuit like this, which uses this chip. So okay, so this is the data memory. This stores what data we have to process on and things like that. And whatever we type here, I have a place where I can type something. So that is an program memory. So whatever I write here will be stored as a program and will be executed. So I can probably load an example code and show you how it works. Okay, so we have some registers on the chip. So these registers are 8 bits. You know what an 8 bit is. So I can store values which can be maxed till 8 bits. So there are some registers called as A, C, C, and B. ACC is called as accumulator. B is another specific register. There's something called as IP, IE, stack pointers, things like that. We will discuss all these stuff. Uh, and then there are some general purpose registers as well, R0 to R7. They are mapped to specific memories. And then there is a timer. So you can let this timer run, and then when it reaches a particular value, you can make a decision. For instance, if you want to do something every 60 seconds, then you can set this timer to 60 seconds. And once the 60 second is done, this timer will tell you that 60 second is done, and then you can do something based on that. And then these are pins. These are the external world pins. For instance, in this board, some pins are connected to this buttons, and these are modeled LEDs. So if I press this button, I can write a code to make this LED glow and things like that. And then there are some analog sensors and digital sensors. So you can use this analog sensor to like sense an analog data like temperature, or anything which is analog, pressure and things like that. If you want to do a digital sense, you can use a digital pin as such for doing that. So that's on a very top. Okay, there is an LCD. I can LCD is a 7 segment. Each of the bits is controlled through an individual line, so I can make one part of it glow. So based on which part I glow, I can make it look like a different number. So that's how a typical LCD works like. So that can be done with that. So this is pretty much what is the simulator which I'm going to use for the class going ahead. And I will start with an with a very basic instruction. We'll go to the slideshow view. Okay, so these are all the instructions possible on a processor. Like you have move, which means you can move data from one part to the other. Move kind of instructions which can move data from one part to the other. Let's say, for instance, the processor can operate only on a particular register A, and then the data is at some other place. You can move the data from that some other place to this register A, in which the processor can process. And then there are some instructions called as push and pop. They do something with stack. If that's too complicated, we'll leave it for now. And then there are some arithmetic instructions. You can do addition, subtraction, multiplication, division, increment, decrement, and things like that. Logical, you can do bitwise, and logical OR and XOR, complement, rotate left and right, data. So all these stuffs we'll learn each of these instructions, and then we will see what it can be used to, and then we can try to construct an application with an 8051 processor. We can try to simulate it here, and then you can also run the simulator on your place and see how it is going to work. And then there are some Boolean operations. Boolean operation means you can process the data bit by bit. You can clear one particular bit of it. I can set one particular bit and things like that. So I will show you what that means. Let's say if I can make this bit E, which means I can set this, clear this bit alone, make one pin low or high. So on that pin, if I connect a relay, I can make I can turn on and light by that. So so a pin can mean a very important thing. So you can make one pin alone individually turned on and off. But let's say, for instance, the importance of having to do it bit by bit is, if it is only that you can change only 8 bits at a time, if they are connected to 8 LEDs, if you want to change one LED, all the LEDs will have to change again. Assume that it is powering something, it is powering an ventilator to a person. Then every time you want to turn on one ventilator on and off, all the ventilators has to be turned on and off, which is not very good. So we will so that's the importance of having a bit level manipulation. So so that's what this Boolean operations can do. And then there is this programming branching instructions, like that is like whatever you write in C, like if else. So that is this. So if this case happens, then you jump to this part of the code. If this case doesn't happen, then you do this part of the code. So if you want to do something like that, then you do branching instruction. So um, um, so that's as good as doing an if else comparison. You want to call a different function based on that if else decision, then you do this branching instruction. So with these instructions, we cover all the logical stuffs, whatever we think we should be able to write using any of these instructions. Let's say if I want to read the temperature, and I assume that the temperature sensor puts the data in one particular memory, I can use this move instruction to move the data from that memory into whatever place I want. If I want to add 20 to that red temperature, let's say I want to convert that temperature in degrees Celsius to Fahrenheit, and if I know the formula, then I can use this add, multiply, divide, decrement, increment instructions to convert from Celsius to Fahrenheit. If I want to check something, I can use this logical OR. And if I want to turn on a compressor, I can use this set bit and clear bit instructions to toggle a particular IO. If I want to jump back and do the same thing, keep looping around it, I can do a jump back to the start of the code so that it keeps looping around the same thing. So I'm just trying to fit in every instruction into this. So that's how we will do most of these steps going ahead. So as a starter, I will start with an add instruction. We are 20 minutes into the session. I'll start. Okay, we spoke about this. So we spoke about all the registers, accumulators, and things like that, and also looked at the code. We are going to use the simulator throughout our discussion. I can give you the link for where you can download the simulator as well if you want to try something on this 8051. So this is what you will do on your labs mostly, but as long as you do it more on a simulator, you don't have to be in the lab every time. You can do it on a simulation and write more code than what you can see in your lab. Okay, writing code is one part of it, and trying to understand how this is going to work is the most interesting part of it. So I'll start with an add instruction. So this is add. So add, the first operand is always A. A is one register of the processor which we saw. So that register is going to be the place where the addition result is going to be finally. So you give add, one of the argument is A, which can have some data like 32 or 33 or anything, and then the other data which you want to add to it can be placed on any of these places. Like it can be an immediate data, Like you can give add a comma 32, then it will add 32 to whatever is there in a already. If a has 30, then it will add 30 plus 32 and give you 62. And or you can point to an address. So this is like pointers in C. So you can point to an address, and then you can ask the processor to take the value in this address and then put it here. Let's say, for instance, like what we discussed, we have a temperature sensor which will go and put the data in particular memory, and you want to read the content of the memory, then you can give immediate RAM. IRAM is immediate RAM, so then you can give the address to it. You can similarly do it with this at operation as well. That's also very similar to a pointer. So if you do at or not, you will see that whatever is there in the address which is pointed by or not will be taken and put on and added to A. So I can show you a quick demo of that. So uh, this is going to be the very first demo, so I will spend some time looking at how things progress. I just want to show you a demo of this pointer. I'm sure you guys have studied pointer on your college, but you find it very difficult to understand. So we will take a pointer to do this. The first thing which you are going to do is an immediate move or not comma an immediate number. If you put hash, it means a number. 20 is 20 is a number. I hope you are able to see the screen. H means it is an hexadecimal number. So I'm going to move a data of 20 to the register R naught. So R naught is a register here. You can see that the value here is 1. So okay, I will step through. So when I do this instruction, whatever instructions is going to be executed now will be on red, and whatever is already executed will be the line before that. So I moved in data a value of 20 into the register R naught. If you remember, R naught is now 1. So after I run this instruction, keep watching this variable R naught. I will try to highlight that. I'll put a this is the place which you have to look at. I hope you can see the highlighter in my screen, or I will okay, or I will mark it. This is the place which you have to look at. So we will see when I execute this instruction. You can see R naught has changed from 0 to 20. Whatever was already there to 20. Now the next instruction is move a comma at R naught. So what it will do is it will go and see the data at the address specified at R naught. So the whatever is there in R naught is 20. So it will go to the memory address of 20 and take whatever is there in that memory and keep it on A. So if it was just move a comma R naught, it would have put uh, whatever is there in R naught into A. It would have put 20. But now, since whatever is there in the address of R naught, the address of R naught is 20. So if I look at the memory 20, if I look at the memory 20, you can see that there is a value of 6 there. So after this instruction, you will see A will have a value of 6. So I will step through. So now you can see that A has a value of 6. I will highlight it for your reference. So you can see that A has a value of 6. So that's how a pointer will work. So I think I will use this to explain how a pointer will eventually work. Okay, so that's R naught and R naught, and also you can add with the data in the register R naught. So R naught is a register. Whatever is there in R naught, if you will add it to A. So similarly, you can do it for all the registers. And opcode is an code which the assembler generates for this command. So if you give a mnemonic of add A comma data to generate an opcode of 24. If you give IRAM address, it will generate 25 and things like that. So this is taken from the book. You can refer to it. So now I'm going to look at an add instruction. Add is very simple. So you add two numbers and put it back. So I'm going to do add with carry a comma 5, a comma R5. So you can see A is a register which is 5, and R5 has a value of 6. So I open up for the first question. I think I can go here, and I have my first question. Hopefully you can see the number written on top of that. You have to go to the website menti.com, and the code for this question is 743858. I can type the code on the chat window. Add instruction is 743858, and you have to go to the website www.menti.com. So you go there and try to answer the first question. So the question is, you have add a comma c. The accumulator has a value of 0x5, R5 has a value of 0.6, the carry register is set to 0. So you have to do an add a comma R5. Find out what will be the answer for this, and then you can click on the answer on the link which I have shared. So this will help me understand whether you have understood the add instructions good. And if I find a lot of people giving a wrong answer, I can repeat the concept and try it again. So that's the purpose of an interactive class. So I request you to go and answer the question on this ID. Another thing is, it will help me ensure that you guys are awake in the class. I know it's an afternoon, so
Students,
it can be tough. Yeah.
students, kindly answer the questions in the given website. Kindly respond for the questions.
Okay. There are 60 people in the class, so I would expect if a considerable, at least 30% people, 50% people answering the question. So in the meantime, while I wait for, I know the first question can take some time to get you open the website, type the code, and answer. In the meantime, if you guys have any question, you can unmute yourself and speak, or if you think it's okay, you can type it on the chat. I will try to answer that. If you think we have to look at something different. Oh, thanks guys, thanks for answering. Okay, please go ahead and okay. The one good thing is you will not see who answered what. I will just see an survey result of how many people have answered what. So I'm on all these instructions, I'm just going to teach you very basic addition, subtraction, increment, decrement, add by 1, and things like that. Okay, I'll wait for the answer counts to reach 20 before I divulge the answer, and then we can discuss what went right and what went wrong. Okay, so if you think, okay, I just thought I will speak about 8051. I had a discussion with your professor and thought we will speak about 8051. That's the plan of the class. If you have, we will try to devote more time towards that. But if you have something else as well, like you want me to teach or discuss some other thing, like a transistor or an or a FET or anything for that matter, you please let me know. Probably we can spend 20-30 minutes on a simulator like this, and then try to understand how a transistor works or things like that. So if that interests you, then we can spend some time on that as well. Okay, I have 14 responses. I'll wait for another 5 more response to gauge how things are. Yeah, the spread is too bad. I mean, like, everyone has answered on all the corners, so that is that's a bit saddening, but that's fine. So okay, I have 20 answers. So add C, I did 0x05, and R5 is 0x06. So this is your class 10th maths addition. So like if you add 0x05 and 0x06, you don't get 0x11. So whatever is there, so this answer is wrong. I'll use a drawing tool to, okay, this answer is wrong. Okay, so this is wrong because addition of 5 and 6 is not 11. It's not 0x11. So I'm going to open a calculator, and then we are going to see what a calculator says when you add 5 and 6. I gave a hexadecimal 5 and a hexadecimal 6. So when you add hexadecimal 5 and 6, you get a hexadecimal B, which is 11. So 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 that means both these answers are wrong. This is wrong as well because it's addition of 5 and 6 in hexadecimal is not a hexadecimal 11. Hexadecimal 11 is actually a different number. It is 17. So if you look at hexadecimal 11, hexadecimal 11 translate to a decimal of 17. This is the calculator on your computer. So this is oh man. This is the norm view which you get. Okay. This is the normal view which you get, but you can go to this programmer's view, which if you press Alt 3, and that will give you an idea of how the other screens work. Okay, so 0xb is probably one of the options, or this can be an option, and unfortunately this is also wrong because when you add 5 and 6, you don't get a carry. Carry is something which will set if only when there is an overflow. So like if the result cannot be held within that space, for instance, if you add 99 and 1 and you want to store it on two numbers, two places only, ones place and the tens place, you cannot store it. If you just look at the zeros place and ones place and tens place, if you add a 99 plus 1, it will say that the answer is 0, but that's wrong. We have to take the third place also. But in this processor, there is only 8 bits. So if you add two numbers and when the result is more than 8 bit, then that cannot be stored within that range. So only in that case, a carry flag will be set. So as long as that is not the case, the carry flag will not be set. So that leaves us that this is the right answer. Uh, so we will go. Okay, so that is the first question answered, and thanks for responding, most of the people. And this is I believe that this it's an interactive way to learn things. I will try to execute the same thing on this processor. Mm, I have to do some groundwork for that to work, so I've done that part. So now I'm going to step okay, we are pretty much on the same case as what is there in the problem statement. I have R5 as 0x06 and AC as 05. So I'm going to add that and then try to look at what is the result. So the result will be available on the register ACC. Now it is 5. When I step through it, you will see that ACC is B, 0x0B, and the carry flag is not set. Carry flag is one of these flags. We'll try to look at the carry flags later. Okay, and just to make the discussion interesting, I didn't give 0xb as the option, so I just gave the hexadecimal decimal equivalent of that. So the equivalent of b is 11. Just to make the problem bit more interesting, I gave that as the question. Okay, now 10, 17, okay, 20, 27 people have answered. That's very good. Okay, I'll go to the next question. Okay, I think we haven't spoken a lot about carry flag, so I will leave this question for now. I will go to, I have the same question with add instruction. Just to reinforce the concept, we will go ahead and look at the same thing again. Okay, if this is a bit too much. Okay, we will start with this. I have an instruction called as ADI, which will add immediate. This is on a different processor called as an 8051, but this also does the same addition. So it will add whatever is there in A with the immediate value. So you can treat it as add A comma 32. So 32 is the number which I have to add with the register A. He already has a value of 0. I want you to find out what is the value of the A register after the addition. To answer this, you have to go to this place 69788. You have to go to menti.com and type this as the login code to answer this. We'll again wait for you guys to go to this link, answer this. In the meantime, if you have any questions, you can feel free to put it on the chat window or open up and talk. Okay, thanks for answering. I have 8 answers now. I'll wait for some more time to see if we can reach 20 answers on this. Okay, if you want to make the waiting time more productive, feel free to ask questions on the chat window. If you ask something, I will try to answer that. By that way, we don't have to wait for everyone to answer. We can cover some topics, so cover some discussions, any questions you might have on the chat window before while we do the answering part. Okay, there are 17 answers. I'll wait for some more time. Okay. Still, I don't see any questions on the chat window. Uh, the more we talk, the more I can know about you. I mean, we are going to spend at least the next 2 hours. So the more I know what might interest you, what what can be of a good learning to you. At least for the next class, I can prepare for that. So the more you express and type things on what you want to learn, that will be good for me to prepare and good for you to understand. So I request you to reconsider the idea of not typing on the chat window. எவ்வளோ பேசுறீங்களோ அவ்வளோ நல்லது. எனக்கு வந்து உங்களுக்கு இது புதுசாக உங்களுக்கு தெரிஞ்சுக்கணும், கிளாஸ்ல இப்போ இது படிக்கிறோம், இதை வேற ஒருத்தவங்க சொல்லி கேட்டா எப்படி இருக்குன்னு நாங்க பார்க்கணும். இதை படிக்கிறதுக்கு ஏதாவது ஈஸியான வழி இருக்கா, இதை எப்படி நான் ப்ராக்டிக்கலா அப்ரோச் பண்ணி புரிஞ்சுக்கிறது, புக்கில் படிக்கிறது புரிய மாட்டேங்குது, அந்த மாதிரி எது இருந்தாலும் நீங்கள் இந்த இப்போ சொன்னீங்கன்னா அட்லீஸ்ட் நான் நெக்ஸ்ட் டிஸ்கஷன் நமக்கு இன்னும் 2 hours இருக்கு, அதில் நம்ம என்ன பேசுகிறோமோ அதில் ஐ கேன் ஸ்பெண்ட் சம் டைம் டு டிஸ்கஸ் அபவுட் தட். ஓகே, I have 7 plus 6 is 13, 22 answers. Okay, again we will spend some time to understand what has been answered and on what is right and what is wrong. Oh man, I don't find that highlighter.
Students, feel free to questions. Students, anyway, this subject you're going to study in the coming semester. 5th semester, you have the subject called microprocessor and microcontroller. So better feel free to ask questions and make use of this session properly. Then only it will be interactive one.
Thanks, ma'am. Okay, so now we have 32% of people answering 32 and 41 as 0x32. Unfortunately, 0x32 is wrong. We can spend some time to understand that. So we are going to add two numbers. One is 0, the other is 32. So I'm going to add 0 plus 32, which is 32 in decimal and 0x20 in hexadecimal. So the answer is 32 in decimal is right. 0x32 in hexadecimal is not the same as 32 in decimal, and 20 is not the same as 32, like you know it, right? So if the answer was 0x20, it is correct, but the answer is not 0x20. The option given to you was just 20. So if I give 20 as a decimal number, then the hexadecimal equivalent of that is 14. If I give 0x32 as the number, then the decimal equivalent of that is 50. So we are trying to add 0 plus decimal 32. So the answer is a decimal 32 or a hexadecimal 20. So option 2 and 3 are wrong. Option 1 is the right one. Yeah, so that's what I tried to reinforce by the first question, and then we thought we'll get some sanity over that in the second question, but unfortunately we still don't have. So I think the very basic thing which you have to do is to go and look at math. um, I will spend a couple of minutes on number systems. I know this can look very primitive, but looking like spending a couple of minutes to look at that is you know okay, first thing I'll start with this saying, like there are oh man. Okay, so this is how the saying goes. There are 10 number of people, those who know binary and those who don't. uh, the joke in that is that if you treat 10 as an binary number, 10 as binary, uh, then the equivalent of that is 2. So if you read it this way, then it says there are two numbers of people. It should have been types of people. there are two types of people: those who know binary and those who don't. So that's basically a fun way of trying to tell people that there is something called as binary number system. So in binary number system, you have only two numbers, 0 and 1. In decimal, you have 1, 2, 3. We also would have read about this octal number systems and things like that. So it has 10, and there is hexadecimal, which goes like this. Okay, I should have started with 0. So this is how it looks like. So here after 9, the number is 10, but here the number after 9 is a, and the equivalent of a is 10, and the next number is b, the equivalent of b is 11, the next number is c, and then here after f the number is 10. So 10 comes here, but here 10 comes here. If I keep numbering that, b is 11, c is 12, d is 13, f is 14, e is 14, f is 15, and then only this comes in. So this is pretty basic math, which is what we have been doing all through our life. So this is 16. So this is the conversion system. So all the conversions which you do in the classes will be like this. So you try to convert one decimal system to other. So 0 maps to this, 1 maps to this, 11 maps to this, 14 maps to this, and things like that. So this is the equivalent number. So when you convert from one decimal system to other, one number system to other, use this conversion techniques to derive the equivalent number. So all the problems involve some amount of conversion between them. So if you understand the number systems very effectively, then I think you should be able to answer most of these questions. Okay, now that being said about the number system, I think we have covered add instruction pretty well. There are some complications to it, like how to store the numbers, whether the results goes out of the range in which it can store it. That's the add with carry. So we'll spend some time on that. So we have to add two numbers, okay, but you can only store it on 2 digits. So let's say we add two numbers. Let's assume that it is decimal numbers only. So we add these two numbers. So if you add them, we get 1 1 as the result. But the only catch there is that you can only remember two numbers at a time. So if you add these two numbers, you can remember the two numbers. But then you are given with this problem where you have to add 99 plus 35. But here also, after addition, you will only remember the two numbers. So when you add that, this becomes 4, and this becomes 12 and 13. So the result is actually 134. But what happens is, because of your memory issues, you can only store you can only remember two. Let's say it's like நம்மளால ரெண்டு நம்பர் தான் ஞாபகம் வச்சுக்க முடியும்னு வச்சுக்கோங்களேன். ஸோ நம்மளால ஆடிஷனோட ரிசல்ட் வந்து 3 நம்பர் வந்தாலும் நம்ம 2 நம்பர் தான் ஞாபகம் வச்சுக்கிறோம். அப்படின்னா அந்த மூணாவது நம்பர் நம்ம மறந்துட்டோம்னா, இப்போ 99 35 ஆட் பண்ணி நம்ம ரிசல்ட் வந்து 34ன்னு சொன்ன மாதிரி. ஸோ ஈவன் தோ ஆனா ப்ராசஸருக்கு அந்த வித்தியாசம் தெரியாது. ஸோ ப்ராசஸர்கிட்ட கேட்டிங்கன்னா 99 35 ஆட் பண்ணா எவ்வளவுன்னு கேட்டிங்கன்னா அது வந்து 34ன்னு தான் சொல்லும். இப்போ நம்ம தான் என்ன பண்ணணும், அவனுக்கு வந்து 2 நம்பர் தான் ஞாபகம் வச்சுக்க முடியும் அப்படின்னு அதுக்கு சொல்லி அந்த 300 நம்பர் எவ்வளவு அப்படிங்கிறத கண்டுபிடிக்கணும். ஓகே, ஸோ as a precursor for that, I will create one question. I didn't have that question before, so I will just have to create it now. The question is very simple. What is the maximum number that can be represented by an 8-bit of data? Okay, that's the question. I will while you can think about the answer, I'll just open it up as a question so that you can answer it as well. I will use a multiple choice question, and the question is, what is the maximum number 8-bit memory? Okay, I have the question ready. I've presented it. So the question is, what is the maximum number an 8-bit memory can represent? You can choose to answer that with this code 191241. We'll try to base our discussions based on the answer you are going to give. I know it's a slightly complicated question, but this is okay. That's very okay. I'll wait for some more answers. In the meantime, wow, this is the most silent. Okay, while you guys keep answering it, I'll try to explain how we should look at that. Okay, we'll start with the very basic bit. So a bit, it's in one place. It can have a value of 0 or 1. So this can store till one number, and then now you have 2 bits. So you can make 0, you can make 0 0 0 1 1 0 and 1 1. So that is in total 4 combinations. Okay, so now if you add one more bit, this is like what you do on Boolean algebra and things like that. So you have the same combination above, 0 0 0 1 1 0 1 1, but I prefix them with a 0, and now I'm going to do the same thing and prefix them with a 1. So 1 0 0 1 0 1 1 1 0 1 1 1. So basically on 3 bits I can represent 8 numbers. You can see that it is getting doubled from the previous time, so it gets multiplied by 2, because on everything you have, for if I do the next thing, I can take everything of this and prefix it by 0, so I have 8 combinations, and then I can prefix it by 1, so the next will have 16 combinations. So similarly in the 16 I will prefix it by 0 and a 16 combination, and then prefix it by 1, I'll have 16 combinations, so the next will be 32. So if I try to look at the numbers, this is not 1, this is 2. So to look the numbers, it's 2 4 8 16 32. I will write them 2 4 8 16 32, and then if I exaggerate it, it is 64 128 256 512 1024 2048 4096 and things like that. It goes on. So what you can see is that it is getting multiplied by 2. If you want to write a generalized formula for it, it is 2 raised to the power x, where x is the count of it. So if you do from 0 to 1, this is 1, 2, 3, 4, 5, 6 and things like that. So 2 raised to the power 0 is 1, 2 raised to the power 1 is 2, 2 raised to the power 2 is 4, raised to the power 3 is 8 and things like that. So that's the idea. Okay, so maximum number of bits an 8-bit combination can represent will be, it will take 8. So if you take 7 and 8, so 8 maps to 256. So the answer 256 is right. 127 is a 7 is can be represented by 7-bit. What can happen is, if you want to represent number from 0, you can do from in an 8-bit, you can do from 0 to 256. But if you want to actually do a signed number, which means that you have to represent on both sides, then this 256 should get divided by 2, because you have to give half of that to the left hand side of 0 and half of that to the right hand side of 0. So that is what it represents as 127. And 99 is probably a decimal number of it. So only if you have 2 digits, only then that 99 comes in. So I think only a very few number of people have answered 4 and 3. So most of you have answered 13, which means that you have well understood the number system for which can be very useful for us in the discussions going ahead. And I think I'm done. So I have completed my. It is almost 1 hour from now. I'll wait for a few minutes to see if you have any questions. If you have anything, you can ask me. Either type it on the chat window or unmute yourself and speak. If not, then the next plan of action will be that we'll meet back. If you have no questions, then the next plan of action is that we will meet back on Friday, and then go ahead and complete some more microprocessor instructions like OR and rotate and things like that. They can be that's like logical operations, so that can be a bit more interesting than this. We'll have similar puzzles for them. We will try to solve them, and by means of solving that puzzle, we can try to understand that. If you want a change of topic, do something else on the discussion. If you haven't let me know, I wouldn't know. If you want to do that, please let me know now, or you can communicate it through your sir or anything like that. And that brings me to the end of the session for today.
Thank you, sir. Students, if you have any queries, kindly ask the query. You can unmute yourself, or even you can post your questions in the chat box.
Okay, that's fine. I'll sign. We can sign off for the day, I guess. But probably from the next time I come in, I'll probably call people by the name they have put on the chat window and ask you to speak if if it's not that interactive. Thank you, guys.
Sure, sir. Thank you, sir. Thank you, sir, for your informative session. And we'll hope for 2 more sessions on Thursday and Friday, sir. Thank you once again, sir, for accepting our invitation. Thank you,
Yes,
sir.
ma'am. Thank you.
Can we leave the session? Move to
Students, if you are in need of the presentation, we'll share the PPT after getting the permission from the speaker. right? And one more thing, if you people are sitting idle like this, then the session won't be an interactive one. This is conducted only for the benefit of you people. Yesterday's session also only few persons are responding to the speaker and others are keep on sitting idle, right? This is not an encouraging sign. So you must make the session interactive by asking some questions. Yesterday he take a subject which you have already studied, EDC. Even in that subject also you are not showing your interest in asking questions or even answering for the questions what he asked, right? This is not good at all. So tomorrow make the session interactive by at least responding to those questions which is asked by the speaker, right? Okay, ma. Now you can leave the session. Thank you.
This conference will now be recorded.